Hello and welcome to Trevor's Tutorials. I'm Trevor Slocum. In this tutorial, we'll talk about what the origin point is and how it's used in EbiTengen, a bit more about the tick rate, how to handle keyboard input, how to add a basic gravity simulation, how to move a player character around the screen, how to check for collisions between the player character and the top and bottom edge of the screen, how to embed asset files within our program binary, and how to load and draw images. The origin point is a fixed point of reference in relation to some geometry. And with EbiTengen, the origin point for every image we load is at the top left, or 0, 0. When we want to draw an image on the screen, the XY position that we give EbiTengen is where EbiTengen is going to start drawing the image starting with its origin point. So that point that we give to EbiTengen, we're basically telling EbiTengen where we want the image based on its origin point. EbiTengen has a default tick rate of 60 ticks per second, or about every 16.6 milliseconds. Any key press or release events must occur at least one tick apart for us to observe them. If a key is pressed and released in the time between two ticks, when our update method is called during that second tick, we would only see the key in the release state. So we need to set a high enough tick rate so that we handle all of the input events. But if we set the tick rate too high, we'll use too many system resources. For instance, on a battery-powered device, we'll drain the battery more quickly. If we set the tick rate too low, then some input events might get missed. I've found that 100 ticks per second generally works well. When we're handling keyboard input, if we only want to know whether a key is currently pressed, but we don't mind if it's been pressed for a while or it's just first being pressed, we call ebiten is key pressed. When we want to know if a key is just first being pressed, meaning this is the first frame, the first call of our update method, where this key is being pressed, we call input util is key just pressed. In this game, we'll only move the player character up and down the screen. In order to do that, we'll need to create a player Y position variable and a player Y velocity variable. In EbiTengen, the Y coordinate increases as we move down, so a positive Y velocity would mean the player character is moving down the screen. In order to simulate gravity, we'll just gradually increase the Y velocity up to a maximum fall speed. To move the player character around the screen, we'll apply the Y velocity by updating the character's Y position. Or in other words, we'll just take the current Y position and add the Y velocity to it. Here in the first tick, the player's Y position is 100 and the Y velocity is 0.5. In the second tick, we've applied the velocity and the player's Y position has shifted down to 100.5. In this game, we'll check for collisions between the player character and the top and bottom edges of the screen. The character image is 16 pixels wide by 16 pixels high, and we'll draw the top row of the image at the player's Y position. Since the image is 16 pixels high, that means the bottom row of the character image is going to get drawn 16 rows below that position. To check for a collision between the player character and the top edge, we just check if the Y position is less than 0. But for the bottom edge, we need to subtract that height of the player image because we're checking against the origin point of the player. When we compile our program, we end up with a single executable binary. So if we want to use asset files like images, audio, or anything else with our program, we have to include them somehow with the program. We could just include them with the binary in an archive file like a zip file, but it's easier if we embed the files directly into the binary during compilation, and that's what we'll do in this tutorial. By default, our program doesn't understand what a JPEG or PNG image is. In order to load one of those types of files, we need to import the appropriate image encoder-decoder package, and typically we can find those in the Go standard library. Once we've done that, we can read and parse image data from embedded files. In order to draw an image onto the screen, we need to specify where to draw it using a geometry matrix. The geometry matrix has a lot more uses beyond just specifying a position, and we'll get into that in upcoming tutorials. For now, let's see some code tying all of that together. So here we have our game.go file, and we'll import the image PNG package using an underscore because we don't directly reference the package, but we want it to be included in our program. Since this is imported, we'll be able to import PNG files. We define a assetFS variable, which is a virtual file system that will contain any files and directories in the asset directory. So any files like images or audio that we put in asset will all be included as a virtual file system here. We define a few constants, the screen width and screen height, and the player's size. We define a function to load an image. Here we retrieve the file from that virtual file system, decode it using one of the packages that we imported earlier, and finally pass that onto EbbyTension. That gives us the actual EbbyTension image type. In our game, we define a few fields, including the player image that we're loading. And here we define a reset method, which will be called when the game first starts and whenever the player goes out of bounds. And all we do here is center the player. We define a method named initialize that we'll call one time when our game first runs. Here we'll set up the initial game state and load any assets. In our update method, we'll check if the Enter key has just been pressed and if the Alt key has already been pressed. If that's the case, we'll toggle the full screen mode. We'll apply gravity by specifying a maximum fall speed and gradually increasing the player's Y velocity until that limit is reached. We add a jump ability by checking if the space key has just been pressed and setting the player's Y velocity to -1 when it has. We apply the velocity, meaning we actually apply the movement, by adding the velocity to the player's current Y position. And finally, we check if the player is colliding with the top or bottom edge of the screen. In our draw method, we'll draw the player onto the screen by creating a draw image options instance and then translating the geometry matrix by the player's current X and Y position. In our main.go file, this time we'll add set full screen true, vsync enabled true, and we'll set our TPS to 100. Launch our game, and there is our first game created using EbbyTension. In the next tutorial, we'll learn how to make things more interesting by adding some obstacles. See you there.